This problem I posted a few weeks ago proves to be very controversial, even with an American maths professor posting a response video to say why the answer wasn't a third, as I was claiming. Now, I'm 100% sure the answer to this problem is a third. I would even bet my vital organs on it. But I'm going to slightly improve the wording of this question to make it a bit less ambiguous and try to explain it in a clearer way than I did before. This problem was shared to me during my PhD at Oxford by a friend who now works for Meta AI. So let's read the problem again. One of my two children is a girl, and here she is. What's the probability my other child is a girl? And I'm claiming the answer is a third. Now, a lot of people are saying I should have used the phrasing, at least one of my children is a girl. But the thing is, I am actually referring to a specific child, which is why I've now added the words, and here she is. Because otherwise, there's no way to refer to the other child. A lot of people were suggesting that BG is the same as GB. But I actually want to consider the children in a specific order, let's say from youngest to oldest. And if we do that, there's an equal weighting between families with two boys, or families with the youngest a boy and the oldest a girl, or families with the youngest a girl and the oldest a boy, and families where they have two girls. And hopefully we can agree at least on that. Now, I showed you that one of my children was a daughter, so therefore it can't be this scenario here. So we're left with three types of family, each with equal weighting, where at least one of the children is a girl. Now, the key to this problem is that when I presented a girl to you, I wasn't choosing a child at random. I wasn't showing you specifically the youngest child, for example. I was actually able to choose one of my children to show to you. So you can't consider each child in isolation. We're considering both the children at the same time. So for this family, when I'm summoning my daughter, I'm specifically choosing my older child to show to you. And with this family, when I show you my daughter, I'm specifically choosing my youngest child to show to you. And with this family, I can show you either of my daughters. Now, out of those three scenarios, only with this third scenario is my other child a girl. And therefore, the probability is 1 out of 3. This is quite similar to something called the Monty Hall problem, which I'm going to cover in a future video. Now, if I modify the original question, so I refer to my youngest child, then the probability would be a half. So if I said my youngest of two children is a girl, and here she is, what's the probability my other child is a girl? This time, I wasn't able to choose a child to show you. It was specifically my youngest child that was the girl. Now, the gender of the older child is independent of the gender of the younger child, and therefore there is a half chance my older child is a girl and a half chance my older child is a boy. So the answer to this question would be a half and not a third. But that's not the same as the original problem I presented.